Hi, welcome back to LeetCode. So in this video, I am going to discuss LeetCode problem 3537. Fill a special grid. So you are given a non-negative integer n representing a 2 to the power n into 2 to the power n grid. So you must fill the grid with integers from 0 to 2 to the power 2n minus 1 to make it special. A grid is special if it satisfies all the following conditions. So what are those conditions? First condition is that all numbers in the top right quadrant are smaller than those in the bottom right quadrant. Next condition is that all numbers in the bottom right quadrant are smaller than those in the bottom left quadrant. Okay, and also all numbers in the bottom left quadrant are smaller than those in the top left quadrant. So each of its quadrants is also a special grid. Okay, so we have to return the special 2 to the power n cross 2 to the power n grid. So any 1 cross 1 grid is special. Okay, so that means suppose we actually have this matrix. So I can divide this into 4 quadrant, correct? This is the block. Suppose this is actually the S1, this is S2, this is S3, this is S4. So the first condition is that all the numbers in the top right quadrant are smaller than those in the bottom right quadrant. So all the numbers that are present in S2 should be smaller than S4 that are present in the bottom right, those in the bottom right quadrant. So whatever the number is present in this block S2, all are actually smaller than the S4. Those are numbers present in the S4 that is greater than this S2. Clear? Next condition is that all the numbers in the bottom right quadrant are smaller than those in the bottom left quadrant. So whatever the number actually present in S4, that is smaller than the number present in S3, block S3. So that means we can write this in this way that whatever the number is present in S2, that is smaller than S4, and whatever the number is present in S4, that is smaller than S3 in this bottom left quadrant, and all the numbers in the bottom left quadrant are smaller than those in the top left quadrant. That means, so S1, so whatever number is present in S3, that is smaller than the S1. We can write this condition is clear. What they are trying to say, this is the condition, we have to satisfy this. Now each quadrant also is also a special grid. So that means what? So n is equal to 1. Suppose we are starting from n is equal to 1. Okay, let's assume n is equal to 0. N can be 0. So that then what will be our grid size? Grid size will be 2 to the power n into 2 to the power n. So here 2 to the power 0 into 2 to the power 0, that means 1 cross 1. Okay, so what will the range of value? 0 to 2 to the power 2n minus 1. So 2 to the power 2n means 2 into 0 minus 1. That means 2 to the power 2n minus 1. Yes. So this is 2 to the power 0 minus 1. So this is 1 minus 1, 0. So value will be 0 to 0. Okay. And the matrix size is 1 cross 1. So ultimately actually one element will be present. So what will be the value for this field? It will be 0 only, because only one element actually we can choose. This is clear. Next is n is equal to 1. So what will be grid size? 2 to the power n cross 2 to the power n. Now that means what is the number of rows and number of columns in the grid? That will be 2 to the power 1 into 2 to the power 1. That means 2 into 2. 2 rows, 2 columns. Correct? So 2 rows and 2 columns. So this is the matrix. Now what will be the values can be present in this matrix? That is starting from 0 to 2 to the power 2n minus 1. So maximum value will be what? 2 to the power 2 into 1. Here n is equal to 1 minus 1. So this is 2 to the power 2 minus 1 means 4 minus 1. This is ultimately 3. So the range of values is 0 to 3. Now what they mentioned that this the value should be sorted So we know that this whatever the number is present in S1, S2, S3, S4. So S2 will contain the smallest number. You can see this condition, this S2 is less than S4, S4 is less than S3, and S3 is less than S1. So maximum value will be stored in the S1, and minimum, the smallest value will be stored in the S2 region. Correct? So what is the minimum value in this? I can actually have 0 to 3. So minimum value, the smallest value is 0. So I will write 0 here. Okay. Next smallest value will be present on which cell? This cell S4. Because what is the condition? S2 will be less than S4, S4 is less than S3, and S3 less than S2. So 0 is the smallest value, it will present in the S2. Okay, and the next value will be stored in the S4, because we will only have the limited number, we only have the 4 number, 0, 1, 2, 3. Correct? So 0 I have already placed in the S2 block, and next smallest number is 1. Or actually I should place, this should be placed in S4, so I will write here 1. Next smallest number is 2, that should be right in the S3, so we will write 2 here. Next smallest number is 3, so I'll write here in this. So this is our answer for n is equal to 1. Correct? Next is n is equal to 2. So n is equal to 2. That means what is the matrix size? 2 to the power n into 2 to the power n means 2 to the power 2 into 2 to the power 2. So that is 4 cross 4. Okay. So this is 1, 2, 3, 4. 1, 2, 3, 4. So this is 4 cross 4. Now what are the ranges of values? This will start from 0 to 2 to the power 2n minus 1. So maximum value will be 2 to the power 2 into 2 minus 1. So 2 to the power 4 minus 1. So that means 4 means 8 into 2 16 minus 1 15. Correct? 15. 0 to 15. 0 to 15. Now what should actually place? What is the minimum value? 0. So how actually it should place? So first of all, what actually I can design. So this is the first quadrant. I have divided this into 4 block. Correct? This is suppose S1, S2, this is S3, this is S4. Correct? Next is, so they mentioned that the each quadrant also should be a special grid. So this S2 also have to be special grid. So it should be, so I can actually divide this into 4 block again. So I should divide this, I will divide this in this. Okay, so this will be S21, this will be S22, this will be S23, this will be S24. Clear? And we know that whatever the value actually present in this S2, in the S2, that should be smaller than whatever the number is present in this block, this S3. Clear? All the number that is present in this 4 number, suppose X, Y, Z, A. So these 4 numbers should be less than B, C, D, E. Correct? And this is a nested condition that they mentioned that each quadrant should be also a special grid. So that means Y should be less than A, and A should be less than Z, and Z should be less than X. Clear? So what do I have to do? So I know that my smallest value is 0, next is 1, next is 2, 3, 4, in this way up to 15. So first 4 smallest value we will have to place in this block, in this S2 block. That means S21, S22, S23, and S24. Clear? So ultimately what will be the value I have to write here? X, Y, A, Z. So that ultimate value will be, so this should be 0. Next value I have to write here actually 1. Here I have to write 2. Here I have to write 3. Clear? You can see that this this quadrant also is special grid. Correct? Because top right is less than the, what is the bottom right. and that is also less than the bottom left, and that is also smaller than the top left, correct? This condition is satisfying. 0, like this condition, S2 less than S4 less than S3 less than S2. Clear? Now next, this is the large block that I have to satisfy the condition that whole the number is present here, that should be actually greater than the present in this block. So next block I have to fill this block, this S3. So what should be the value? So what should be the values here? So next is 4. So I have to place first 4 here, then I have to place 5 here, then 6, then 7. Clear? Just observe actually the flow. Next, this is actually special grid now. Next, this block should be S4 should be less than greater than S3, correct? So 8 I have to place here, then 9, then 10, then 11. Then S1 should be greater than S4, so 12 will be first, and also it has to be also a special grid, so that's why 12 I will first place here, then 13, then 14, then 15. Got it? So this actually the recursively we have to fill this block. Means first of all try to fill this this rightmost top right block. Then after completion of this block, I will start filling in this block S3. Then I will start filling up the S4, and then I will have to go S1. Clear? And when actually, what is the base case? When the size is actually, when the row size is actually 1, so that is the base case. And what is the value I have to place? So I know that first I will go top right in this way till our size is equal to 1. So first of all I will reach in this cell, so I place 0, and I will increase the value as 1 from 0 to 1, because I have already placed 0. Next available smallest value is 1. So after completion of this, I will return from here and I go to the actually bottom right. So I will come to this cell. So what is the next available number? 1. I will place here. Next I have completed this. Next I will return from here, and what is the next? I have to go bottom left. So I will come to this cell and I will place the 2. Next I will go to the top left, and what is the next value? 3. I will place here 3. Clear? Next I will go, I have already completed this quadrant. I will go to the next quadrant. Okay, next quadrant, and this size is not equal to 1. So I will again go to the actually nested hierarchy. So nested hierarchy is this will be the first. I will go to the actually top right. So this is top right, this cell. So next available number is 4. So I'll place here, and the size is also 1. So I'll return from here. Next I'll go to this bottom right, and next available number is 5. So I'll place 5 here. Next I'll go to bottom left. Got it? In this I have to solve this. So you actually got the actual point how actually getting the output. So first of all find the go to inner grid, inner quadrant, that will be better. Okay, till our row size is not equal to 1. So this is the base condition. Whenever is the size row, only one row is present, so that is the inner condition, base case. The only one cell will be present on that 1 cross 1. So on that cell I will place the value, whatever the smallest value I actually have currently. Now how actually we will go to the actually the nested or inner quadrant. That is first I have to go top right, because this is contain the all the smallest number. Then I have to go bottom right. Then I will try to fill bottom left. At the end I will try to fill up the top left. Correct? This is clear, the steps. Now go to the code. Now you can see that how recursively we can solve this problem. So how many actually rows actually I have? Row and column both actually same, 2 to the power n. So that's why actually I've shifted n times. So this is actually 2 to the power n. So this is the number of rows and number of columns. So the matrix size will be this row into column. So row and column is same. So that's why I've taken a grid of size the same row into a column. Got it? And I have written this ultimately because I have written this matrix ultimately. Now I'm calling this helper function solve, or is passing what this grid, or actually I have to store the fill up the values and the initial row and the total maximum number of rows can be, and the starting column and the maximum column actually I can have, and ultimately after filling up in this special grid, I'll return this return the grid. Okay, and the value will start from here 0, and I don't need to check the 2 to the power 2n minus 1. Why? Because ultimately how many actual cells are present in this grid or in the matrix? Total number of cells will be 2 to the power n into 2 to the power n. So if I actually add this, so total how many actually cells are present? 2 to the power n into 2 to the power n. So 2 to the power n plus n. So 2 to the power 2n. As I starting from 0, so it will go up to 2 to the power 2n minus 1. Got it? If I start from 1, then it will 2 to the power 2n. But we are starting here from 0, so that's why it is 0 to 2 to the power 2n minus 1. Got it? So that's why you need to check that this is within range or not, whatever the value is placing, because ultimately that means actually cells are present actually ultimately. So I'm calling this helper function solve. First of all, I will pass the matrix. First I will write the value and the starting row and the ending row, means the row size initially, and the column start. This is initially 0 and the column end will be the size 2 to the power n. Okay, so first of all find what is the best case. We have to find that the number of rows is present is 1 or not. So that's why I'll find that how many rows are present. So row of end minus row of start. Okay, this will give us the how many rows are present. So if number of rows is equal to 1, that means what? We have reached the smallest cell. We can't actually break anymore this block, because this is the only one cell which is present. So that's why that is the base condition. And particular in this row start and row column start, I write this value, what is the value actually I have, and also increase the value, because for the next cell I have to write the next smallest value and return from here. Got it? And this is global variable, this int value val. Got it? Next, if it is not a basic cell, means we actually more than one rows. So what I will have to do? I have to again block this, divide this into 4 block, S1, S2, S3, S4. So that's why I will find out what is the mid row. So mid row will be what are the rows start actually I have plus total number of rows by 2. This will give the ending of this like here actually this means, so this is actually we have 4, suppose 2 cross 2, 2 cross 2. So row start will be 0 and row end will be 2. Okay, so how many rows actually I have? 2. 2 minus 0, it will give 2. So if I divide this 2 by 2, it will give 1. So ultimately how actually it end? So 0 comma 1 means only one row will be present, 0 and starting at 1. Got it? And then for the next block, so this is for this block, this is for this block, and for the next block, so I have already divided 0 to 1, and for the next block it will be from 1 to 2. Got it? Similarly for column also. So that's how you can see that mid row will be what? Row start what actually I have, and size actually it is 2 by 2, it is 1. So 0 plus 1, it is 1. So for this example, it will be mid row will be 1 and mid column will be also same 1. Got it? Now first of all, what actually block should actually fill? We should fill up the top right, because that is contain the smallest values. Then we have to fill up the bottom right, then bottom left, then at the end we have to fill up the top left. Correct? So that's why first of all again this calling this recursively this helper function solve grid, passing the grid. Row start will be same and mid row will be this whatever actually new row actually I have divided this. So this will be the new ending row for this block, and mid column, because this is the like kind of dividing this. So suppose this actually 0 1 2, and this is 0 1 2. So I have divided this in this way. So I have divided this in this way. So what is actually the first of all I have to try to fill up this block. So what is the row is 0, starting row, ending row will be 1, because you can see that this is the starting row 0, ending row is 1, and starting column will be this 1 and ending column will be 2, correct? So this is actually the same as the input. This is the mid row, this is the mid column, and this is the same as the input, correct? So you can see that for the top right, whatever passing, row start is the same as the input. Mid row is changed for the this one. Next is mid column, starting of the this column, and the column end, whatever actually input actually I have, that is passing directly. Got it? So in this we will solve this, and ultimately we actually fill up in this. Actually first we will fill up the top right, then bottom right. In this we will create the special grid. Got it? How actually we are using the recursion here. Got it? And it will pass as our n is very the number of n is very small, that is 10. Got it? So it will actually maximum 2 to the power 2n, 2 to the power 2n, yes. So 2 to the power 2n, so n is maximum 10, suppose. So 2 to the power 2n, we can actually maximum, I will iterate all the cells, so it will be 2 to the power 20. So it will be actually 10 to the power q into 10 to the power q, it will be 10 to the power 6, so within the range. Less than 10 to the power 8, so it will actually pass. Got it? So if you have any doubt, any suggestion, you will comment on that. And if you have not yet subscribed, please subscribe the channel. Thank you. And also I have shared this code in the description, you can check that also. Okay, thank you.